All right. Good morning, everyone. Thanks for coming. So early. So it's great to be here. It's really exciting. This is my first time coming to this workshop. I guess 50% of the room is probably their first time, according to those stats we just saw. And I think this is a really interesting area. And so my name is Brendan. I'm at the University of Massachusetts Amherst. I'll be presenting work done with my student Sulin Blodgett, who couldn't be here. And this work is on racial disparity and natural language processing. So what I wanted to kind of highlight and maybe get anything useful out of this talk, I just want to maybe kind of pose a question of maybe a class of problems that seem to have something to do with fairness. And I would love to have more discussions about what the relationship is exactly to what most of the folks here do or whatever. And the idea here is that there's a really important type of artificial intelligence, language technologies, for example, natural language processing algorithms. And in this class of algorithms, these are methods that they're not making decisions about whether to approve a loan for a person or anything like that. But what they're doing is they're analyzing the linguistic behavioral outputs of people. So language is a behavioral process, and language is a very social process. People create language, and people create language in order to communicate with others. And it shouldn't be a surprise that language is affected by social context and social attributes. If you're talking to a student versus talking to a professor, you might say different things. You talk about different things depending on what you're doing, et cetera, et cetera. And so because of this, there's all sorts of implications for how we're going to design things like language technology algorithms, how we're going to design dialogue or whatever. But one very interesting thing, I think, is that lots of the common algorithms we use for natural language processing can be really affected by the attributes of the speaker. Or maybe they have performance or properties that is correlated with the attributes of the speaker. And so a very simple example I think is really great is an example of gender bias in auto captioning for YouTube. So YouTube runs speech recognition on videos to create captions so you can read them if you're unable to hear the audio. And so there's a nice paper by Rachel Tatman earlier this year looking at word error rate conditional on the gender of the speaker in the video. And of course, it's well known, men and women speak differently. If you accept that gender is an interesting social variable, what's interesting is that the performance of a speech recognition system, this particular one that Google has for YouTube, has different performance across genders. And so the error rate up is worse here. The error rate is higher for female speakers than for male speakers. And so if you're familiar with everything that goes wrong in machine learning, you say like, okay, well maybe the training data is wrong, or the training data is skewed in some way, it's not covering everything. But what's interesting about this sort of case is that it has perhaps some implications for what technologies are going to do. So for example, if you're thinking about something like being able to recognize all the speech in a video, there's questions about what information you can access. So if you need to use the captioning because you can't hear the audio, you're going to be able to understand what males are saying better than what females are saying on average. And I think this also has implications for like whose voices we hear, or what sorts of authors have maybe the privilege or the ability to be accessed by all of our online systems. So all of the ways we access information now relies really heavily on something like search engines or machine translation and things like that. We have all these layers of processing for all the language and the text corpora where we want to get information. If we have biased natural language processing algorithms, we're going to be paying more attention to information from certain types of people than from other types of people. And so today I'll talk a little bit more on another kind of case study of this and ask, are there any implications of this fact that language is socially embedded, and what implications are there for natural language processing? And so I'm going to focus on dialect, and I'm actually going to focus on dialect specifically of African American English, which is, anyone heard of African American Vernacular English? Okay, great. And so a major dialect of American English spoken by tens of millions of people, very underrepresented in kind of mainstream, well-edited English. And what's really interesting about it is perhaps surprisingly, I think, there's a lot of it in lots of online forms of media, especially social media. And so I'll talk a little bit about some examples from simple natural language processing and part speech tagging, and also talk about kind of the main thing we have at our paper at this workshop, looking at it on Twitter and looking at how it affects things like language identification, one of kind of a core task in simple language analysis. And so eventually, the kind of overall goal for this research agenda, and I think we're just getting started with it, is to have things like natural language processing tools or language technologies that can work across people who speak different dialects or speak in different ways. And then we can have maybe equitable or fair analysis for what different, the linguistic outputs of different people. So, all right. So I wanted to start off by just highlighting a little bit of linguistic variation online. So here's two words. The first word is AF. Does anyone know what AF means? What's the policy on swear words here? all right, I'll record it. So as F, I'm tired AF. It's very early in the morning, right? You might say something like that. And here's another one, IKR. That's a good one. Does anyone know IKR? This one's rare, huh? Okay, I know, right? It's really early, IKR. And so these words are interesting for many reasons. They're all fairly new to English. And if you look at a 3-year period on Twitter, or the geolocated subset of Twitter, what's interesting is they're kind of rising in popularity over this particular 3-year period. It's approximately 2011 to 2013 or so. And the word AF kind of increases in popularity everywhere. And AF is becoming more and more common. Lots of people at KDD workshop have heard of it. So it's big time. It's not mainstream, right? Another interestingly though, IKR, at least back in this time period, I guess it's more common now, but IKR started off in a particular place in the United States. It spread a little bit, but it did not spread in quite the same way. And there's lots of interesting questions about why did language evolve in different ways. And it has something to do with things like the social networks of the people who are using these things, who are people connected to, what communities are using different types of language. And so this is just to show that there's this kind of embedding in, for example, geographic space, and that's really going to affect what sorts of language people are exposed to or are going to use. And so we can ask, okay, well, there's this socially embedded language online in social media. It could be very interesting to analyze for all sorts of reasons. So a classic one is sentiment analysis. We want to know what people are saying about different things or have different opinions or things like that. And so a really important thing in order to be able, a more thing to do in order to get into social media NLP is to have some sort of linguistic analysis. And so if you look at messages in online media, you immediately see there's lots of cases of things that look like non-standard language. And so here's another real tweet. I want read it for a second, like, okay, I get it, great. And so it's a question of whether this is a noisy text or not. And so you can see lots of alternate spellings for various things. So, FIR, it's not a fir tree, right? And so I would argue that if we want to do something like a part of speech, that should be a preposition. It's being used as a preposition, and it creates a prepositional phrase, and you need that to get a useful semantic parse for a sentence. And so if you want to analyze this sort of thing, you should do a part of speech tagger. It's typically useful to use word clusters on very large unlabeled corpora. This is on something very similar to word embeddings are another very commonly used technology to do this, and it can learn to put these systems learn to put together words that have similar syntactic behavior. And so if you look at examples for Twitter, you get lots of interesting cases of these word clusters of all sorts of very non-standard forms of words that are linguistically different. And so you say, okay, well, the system wants to tag the word FIR. You may get some information by looking at whether words are distributionally similar. This particular algorithm, this is Brown clustering, it's a form hidden Markov model, is finding that the word FIR, at least on kind of unlabeled Twitter, this form unlabeled Twitter, is being grouped with a whole bunch of other words that look like prepositions. So W alone is the word with, for example, on the left there. About dropping the T at the end. These are both versions of for, FOR, etc. And of course, for other terms, you get lots and lots of different variants. And so there's this just huge amount of different variations of words that you see on this sort of media. And there's statistical coherency for it, like anything. You also get lots of other examples. So for example, there's a fun one. So here are two word clusters. They're grouping together all the versions of so. And you get this even without any sort of like character level modeling. But what I think is really interesting is that you get some clusters that, at least when I first looked at these, were not so clear to me at first what these were. So here's kind of two leaf clusters in a particular hierarchical word clustering. So this first one is gonna, going to in different forms. Maybe some spelling variants, things like this. But this other one, this is a trina, gonk, finna, bauda. And so, very roughly, trying to, about to, kind of shortenings of that. Has anyone heard finna before? Few people? Yeah. So finna, maybe approximately fixing to, is implicated in dialects in the US South and African American English. It's not really a word in kind of mainstream standard American English. And so it means, I'm finna eat breakfast. I'm fixing to eat breakfast. I want to eat breakfast. I'm going to do it very soon. There's kind of an immediate future tense there. So that's just another thing that's just in social media if you look at kind of a large corpus of English messages online. And so lots of other examples. But what's also interesting if you look at some of these, and so you can see, here is my random sample demo. So the chances won't work. But if you just look at how people are using these things. So I'm just searching for finna, getting some examples. Finna Breeze, finna Game of Thrones. I'm not going to be just friends with anyone. Any notes about this set of this random sample of messages we're looking at that seems interesting about finna? Great. All right, so I did not plan this. So these things last night. They're not really using a random sampler, right? All right, so I'm going through these kind of fast. You can't even see the content. But the point is the metadata. So if you look at the authors, there's a lot of people who are presenting themselves as African American or are African American, at least according to the profile photos, whatever that means, it's some form of self-presentation. And there's a lot of these if you look at this. And there's many, many other examples. And what this kind of gave us the clue for was that there's something really interesting going on with social media language. And there's certain implications with social variables, in this case, race. Or at least this is kind of some anecdotal evidence for this. So we looked at digging a little deeper, and fortunately we have a colleague in linguistics who's an expert on African-American varieties of English. And so if you study language formally, if you look at any sort of tweet, you can actually see all sorts of kind of interesting things up here. So here's another fun one. If you have a hard time parsing this, there's an utterance boundary after every AF. So it's just missing punctuation. But other than missing punctuation, there are actually a few other interesting things here. So in particular, he woke AF is equivalent to he is woke AF if you're using standard American English. And this is an example of what's called the null copula. So you can say he woke to mean he is woke. And woke, of course, is an interesting lexical item by itself, right? And so this is a particular example of a syntactic construction, which is common in certain dialects of English, and specifically African-American vernacular English. And this is a phenomenon that's very widespread in the United States, been well documented by syntacticians and sociolinguists. And so this kind of comes to the question of why social media language is different. And so there may be two kind of predominant reasons looking at it. And so to a certain extent, things on the internet are different. People are typing things. It's a different mode of communication. But we would also argue that there's interesting boundaries or reproductions of things in dialectical English. And so when you look at any kind of major world language like English or French, there's all sorts of regional dialects or dialects to particular communities. And there's a lot of variation underneath the standardized variant of a language. And when you're getting to information on the internet, when you're getting into kind of casual conversational text, people start using their vernaculars more. And there's all sorts of interesting geographic patterns of word usage that you can see on Twitter that correlate to things like race and others. And a number of researchers have started looking at this in both linguistics and computer science. And also, when you're looking at information online, the people whose data you're analyzing may be different than you're necessarily expecting. So here's some demographic data on Twitter. This is from, I'm going to focus on data from 2013, which is when the dates of most of the data we're using in our study. But if you look at the percentages of people conditional on race who use Twitter, in 2013, especially early Twitter, African Americans were actually quite overrepresented compared to overall US population. And I don't know, some people have heard this hashtag Black Twitter is a thing that's kind of talked about sometimes. But I think it's really remarkable and actually leads to lots of certain types of variation on Twitter. And of course, all the social media systems, or many of them, there's also kind of overrepresentation of young ages also. And so these are also interesting groups because we know from sociolinguistics that people who are young are also often kind of drivers of language change. So, teenagers making up new terms, roughly, right? And so, of course, these things also change over time in various ways. There's still quite a bit of overrepresentation of youths on Twitter. And of course, every social media system is maybe slightly different. And so I want to briefly review what we did is to look for language, is to fit language models, or just unigram language models, that correlate the US Census racial demographics with different types of language. So kind of at the term or message level. We can actually validate what this model learns, showing that the messages it groups together and retrieves actually correlate to linguistic variables that are already known in the linguistics literature, in particular showing that it's capturing African American vernacular English. And then what's interesting is we can use this to kind of investigate the current racial disparities in natural language processing tools in terms of their performance, kind of like what I showed in that earlier slide about kind of the speech recognition example. We'll just be looking at specifically on Twitter. And then finally, I'll just say a word or two about how we're trying to adapt or create fairer natural language processing tools, where fair means similar accuracy across social groups. All right? All right, so first, you have to associate tweets with demographics in some ways. And for all these different internet systems, there's different ways of doing it. So what we did here is we actually used geolocated messages. Geolocation is kind of nice, at least for this era of Twitter data, because it's kind of on automatically, which has all sorts of interesting privacy implications, of course. But for something like corpus-based sociolinguistics, it's extremely useful. And so what we do is we check the racial demographics of the neighborhoods that individual messages are written in. And we're using kind of the US Census block group's granularity of data, which is pretty granular. And so what we do is kind of average together these demographic vectors, and we're focusing on ethnicity and race in this work. And then there we have a way of basically taking the word to demographics correlations. You actually kind of do this directly with any machine learning if you wanted to. We actually use a mixed membership model where we say this information from the census data is used as the center of a Dirichlet prior, and then individual messages can kind of deviate from it in different ways. So the assumption is that people kind of can mix different types of dialects, where dialect means a unigram language model that's associated with a demographic category in the data. And so this is, it has some of the mechanics of a topic model, but it's much, much more supervised than a typical topic model. So we're not sure what to call it. We call it a mixed membership model for demographics and language. But what's interesting about this is that we can then look at what sorts of language it learns and look at some validation of it. And so I'll just give one simple example of this. We can do lexical analysis. So for every word in the vocabulary for a particular topic K for one of these kind of demographic related word distributions, just simply look at the ratio of how likely it is in that against in K versus the rest. And so it turns out that words aligned with African American populations on Twitter tend to be, more of them, 79% of them are non-standard, meaning they don't appear in its English dictionary. Whereas the words that are associated with white populations on Twitter tend to be more standard. And so that's telling us here kind of the biases in terms of race of users or race of users' neighborhoods compared to standardized form of English. And finally, there's also, we have some funnel, you can do analysis of particular words also. So finally, I'll say, we also looked at disparities in language identification tools. So language identification is kind of a key step in natural language processing pipelines. So for example, if you take our favorite message here and run it through a standard language identifier, it says this is Danish with 99.99999% probability. It's not to knock, so LangID.py is actually kind of the best open source language identifier. It's very impressive, but it's not necessarily great at this information. 2 minutes, okay, great. So so we analyzed this a little bit more, and so in our paper here, we looked a lot at the racial disparity and accuracy against a number of variables. And so in particular, what we want to do is we take the messages that are analyzed with our mixed membership demographic model, and we look at messages that are associated with white populations or messages associated with African American populations. Another way of thinking about this is basically messages that are written in kind of standardized mainstream American English, or more so like that, versus messages that display more attributes of African American English. And we can look at disparity, and this is just, you can analyze any off-the-shelf algorithm this way and to look at these sorts of disparities. And so first, here is on the left is Twitter's own language identifier. This is information that's in the metadata of a tweet. There's a kind of little tag that says, here's the language of your message. And for messages that are length 5 or less, so pretty short messages are harder for language identifiers. The kind of standardized American English accuracy is in the kind of 73% range, whereas messages that are written in African American English, the probability of getting them right is substantially lower. There's a large accuracy gap there. And so these are messages where when we do analysis and annotate samples of them, they're all written in English. Maybe a slightly broader notion of English based on the examples I've shown you before. But these are basically messages that these systems are saying are Danish or some other language. They're completely missing them in terms of the language. And so this racial disparity also holds for LangID.py. And so as you get longer messages, maybe the disparity sometimes gets lower and accuracy goes up overall because language identification gets easier with longer messages. We also see racial disparities in some off-the-shelf commercial systems. There's IBM Watson API, Microsoft Azure API, again, all these APIs now. And some of them are better than others. But there could be all sorts of biases, and is it the training data that went into these algorithms? How's the pre-processing done? What sort of engineering decisions were done? And if you're like an engineer making a sentiment analysis system, it's pretty easy to look at Twitter's metadata and just use it without thinking about what this data means or what sorts of biases it might have. And so I would argue that if you're making a sentiment analysis system and you use some of these off-the-shelf tools in a naive way, you might be excluding certain types of voices or certain social groups of people from what your system is analyzing. All right. And so we've also worked on trying to make language identification less disparate. And so, for example, you can do things like a domain adaptation with unsupervised methods by trying to take the outputs of our system and trying to integrate them together. All right, and there's also disparities in lots of other systems. So for example, syntactic dependency parsing, if you're interested in that, that also shows these sorts of accuracy disparities. So higher accuracy for these white associated tweets, lower accuracy for these African American associated tweets. All right, so I should wrap up. There's lots of historical language. There's all sorts of crazy things going on here. I want to say that natural language processing systems almost always are heavily dependent on their training data, like lots of supervised machine learning algorithms, and those are typically designed for the standardized variants of major world languages, such as standard English. And there's all sorts of interesting confounds on how we're going to tackle this and build very fair systems in the future. Right, thanks.